Hello everyone, this video's purpose is to help you with test corrections for Unit 3 Rocks and Minerals. Last test, I had asked people to come after school to help assist you with test corrections, but several of you said that you just couldn't make it, so I figured would be an easier way to do it. What you're going to need to do is have a piece of paper, your Scantron, and your test. You'll go through, and for every question that you got wrong, you're going to write an explanation for how to get the right answer. What I suggest doing is finding the number for the question you got wrong first, fast forwarding the video till you see me talking about it on the screen, listening to it, and then to the best of your ability, putting what I said in your own words as an explanation as to how to find the answer to that question. You'll do that for every question you got wrong, writing an explanation how to get the right answer. And then by the end of next week, so next Friday, you will turn this sheet of paper with your test and your Scantron stapled together and put in your class bin. And you will earn back half of the points that you got taken off on your test. So with that, let's start. The first question, which two minerals are commercial sources of iron? To do this, you need your Earth Science reference table, page 16. When you go to page 16 in your Earth Science reference table, we're going to look in the uses column for something to do with iron. We see iron mentioned here for magnetite. We also see iron mentioned here for hematite. So your answer should include both of those. If we look at the choices, the only one that makes sense is one, which is D. 2, most rock gypsum is formed by the. So we're going to turn to the pages that deal with rocks in your Earth Science reference table. That's pages 6 and 7. If you're not sure where to find rock salt on which table, you could go through and look at each rock until you find the name rock salt. It is a sedimentary rock, so I'm going to go to the sedimentary rock table. Next to rock gypsum in the comments section, it tells us how it forms. It's crystals from chemical precipitates and evaporates. And if we look at question 2, it mentions chemical precipitation of minerals from seawater. Question 3, which statement best describes a general property of rocks? So they're looking for what rocks have most in common. And if you look through all of the rock samples here, we can see all of these samples have mostly quartz and feldspar. We can see these samples have calcite. We can see that these samples down here have quartz and calcite. We can see that these samples over here have feldspar, quartz. So a lot of these rocks have the same minerals in them. So the answer for 3 is A, that most rocks have a number of minerals in common. Question 4, the graph below shows the hardness of 4 minerals. It has muscovite mica, fluorite, olivine, and graphite. And it says, which mineral is hard enough to scratch calcite, but is not hard enough to scratch amphibole? And I wrote a little note here for you to read. It says, if you scratch calcite, you have to have a hardness higher than calcite. And if I look on the back of my reference table, page 16, here's calcite, and calcite's hardness is a 3. And then if I am scratched by amphibole, amphibole must be a number higher than me. If I look here, here's amphibole. Amphibole's hardness is 5.5. So what I did is I went through on my reference table, just like I did with calcite and amphibole, and I found the hardness for each of these and I wrote them down. The only number that is higher than calcite, but lower than amphibole, is fluorite, which is choice B. The next question. Question 5. Base your answer to the following questions on the diagram below, which shows the results of 3 different physical tests, A, B, and C, that were performed on a mineral. This one shows the mineral and how it breaks. So this is its breakage, and they're saying it's cleavage. This one, they're showing an unglazed porcelain tile, and they're showing powder. So this is streak. This one, they're showing the mineral being rubbed on glass. So this is hardness. And then they're going to ask us a question that has nothing to do with the pictures to try and throw us off. It says the luster of this mineral could be determined by. Luster is how light reflects off the surface of a mineral. That's just a fact you need to know. And that's mentioned right here. There are 2 main categories of luster for which you're responsible. Metallic, which look like metals, so your silver, your gold, your brass, your coppers, and then your non-metallic, which can be bright, bold colors like pinks and greens and yellows. They can look earthy like browns and dirt colors, or waxy like yellowy wax or orangey wax. Question 6. The diagram below represents part of a crystal structure. So this is a crystal structure, and the mineral is kaolinite. An arrangement of such atoms as shown in the diagram determines the mineral's physical properties. We talked about that the internal arrangement of atoms, that's what this is, are responsible for all of the physical properties we see of the mineral. Physical properties can be things like their luster, their hardness, their streak, their color, how they break, any special characteristics they have. So 6 is safe. Question 7. Question 7, we have a few rocks up at the top there, and it says, base your answer to the following question on the drawing of 6 sedimentary rocks labeled A through F. So the first thing I'd do is I'd turn to my ESRT page 7, and I'd find those rocks. The second thing says, which table shows the rocks correctly classified by texture? So I'm going to find the column that each of these rocks textures are in. So if I look, here's my reference table. Here's my texture column. So a conglomerate is clastic, breccia is clastic, sandstone is clastic. Down here we have crystalline and bioclastic. So I would go through and figure out what each of these are. So this is clastic, this one's clastic, sandstone is clastic, shale is clastic. When I get to limestone, that's crystalline, or it's also bioclastic. And rock salt is also crystalline. And then I'd see which table has those correctly identified. So A, B, C, and D should all be in the clastic column. Just by going there, the only choice that works is A. Question 8, name the rock and the map symbol used to represent a sedimentary rock that has a grain size of 0.006 to 0.2 centimeters. So I'm going to start by going to my reference table, page 7. I'm going to look for that range that they just gave me, 0.006 to 0.7. So I'm going to go through and see, or excuse me, 0.2, not 0.7. I'm going to go through and see, and sandstone is 0.006 to 0.2. And the rock that makes up is sandstone, and its map symbol is di. If I look here, that most closely resembles this one down here, labeled sandstone. So 8 is D. 9, which type of rock is most likely to contain fossils? To answer this question, you need to know that fossils are only found in sedimentary rocks. So go through and find out which rock is your sedimentary rock. If you're not sure, look all of them up. So I'm going to start with granite. When I find granite, I see that's an igneous rock. No fossils there. Then I'm going to go to gneiss. I search all the names on the tables. Gneiss is a metamorphic rock, so no fossils there. Metaconglomerate, that's on my metamorphic rock table. No fossils there. C is a sedimentary rock. They have fossils formed only in sedimentary rocks. So C is shale. The fossil gets wedged in. It gets buried by overlying sediments. It decays. It leaves a mold. It gets filled in. That's how we get fossils. Only can happen with sedimentary rock. 10. The photograph below shows a magnified view of a portion of a rock that can float if placed in water. Which term best describes this rock? So if we look, the texture of this rock seems to have a lot of holes in it. A rock with holes is vesicular. I don't see any crystals, so this is non-crystalline. So that is choice A. 11. Which texture best describes an igneous rock that formed deep in earth? So I'm going to go to my igneous rock. I'm going to look at the texture column, which is over here, and I want it deep in earth that's intrusive. Remember, the IN in intrusive tells us it formed inside earth. So the best textures would be coarse or very coarse. If I look, the only choice out of those two that they gave me is coarse. So 11 is D. 12. An extrusive igneous rock with a mineral composition of 35% quartz, 35% potassium feldspar, 15% plagioclase feldspar, 10% biotite, and 5% amphibole. So first, they're telling us the rock is extrusive and igneous. So I'm going to take out my igneous rock chart. I'm going to look for the word extrusive. These are rocks that exited the earth when they formed. They cooled quickly. So that leaves me with all of these choices up here. Now, they give me a list of minerals, and one of the minerals present is Mrs. Haining's favorite mineral, potassium feldspar there. Remember that potassium feldspar is a mineral only found in this first column. So when you see it, you know that it's a rock on this side of the chart. Remember that these minerals are in the rocks in the columns above them. So I'm going to follow potassium feldspar up to extrusive, and that gives me rhyolite, vesicular rhyolite, pumice, and obsidian. When I look at my choices, the only one that I said is A, rhyolite. Question 13. Which relative concentration of elements are found in felsic rocks? Back to my Earth Science reference table, page 6. They talk about felsic rocks here on my igneous rock chart. They tell me that they're rich in Si and Al, and that they don't have a lot of Fe and Mg. If I don't remember what those periodic symbols represent, on page 16, they show me. Si means silicone. Mg means magnesium. Fe means iron. Okay, so I'm going to go through and I'm going to read about each of my choices. And the only choice that makes sense is that there's a high concentration of aluminum. That's my Al. And a low concentration of iron. Iron is high on this side, so it's low on this side. Question 14. The diagram below indicates physical changes that accompany the conversion of shale to gneiss. That's important because it tells us that this rock is going through a change. If I want to know how to go from shale to gneiss, I start off with a clastic rock. It becomes slaty cleavage. It becomes obvious foliation. It becomes banding. If I look for the words shale and gneiss on my reference table, I find shale is a sedimentary rock, and I find gneiss is a metamorphic rock. As I move from a sedimentary rock to a metamorphic rock, I have to go through heat and/or pressure, which is metamorphism. The choice there is C, metamorphism. Which physical characteristic best describes the rock phyllite? So I'm going to look for something about its texture and phyllite. Phyllite is a metamorphic rock. Again, if you didn't know that, you could look through the names until you find it. And then I'm going to go over, it says it has the foliation on its surface from mica. It says that it has mineral alignment, and again, it tells me it's foliated. Here it says foliated with microscopic mica crystals, so 15 is D. 16, rocks can be classified as sedimentary, igneous, or metamorphic based primarily upon their origin. This is the lab we did in class where you rolled the die and you traveled all over the room, and based on what you interacted with, where you were placed, that determined what type of rock you are. And that's what this table here is showing us, that really what's determining if you become igneous or sedimentary or metamorphic is where you're coming from, where you started it from, and where you're going to. So if I'm a sedimentary rock, that means my origin was I was compacted and cemented and buried. I started off as sediments. If I'm an igneous rock, I started off as magma and I solidified. If I'm a metamorphic rock, I went through heat and/or pressure. 17, the diagram below represents a rock consisting of granite pebbles and sands cemented together. How does the age of the granite pebbles compare to the age of the rock itself? Well, for these pebbles to be in this new rock, they must have existed in another rock, been broken off, cemented together, and formed this new rock. So the pebbles are older than the rock. '18, which rock is formed as a result of these three stages? So they show us three pictures above. They tell us it is the specific formation of a rock. It says the remains of a partially decayed plant. The burial process is being produced from the overlying sediments, and then further burial creates more pressure. So in those three stages, we are going to form coal. What they're showing us here is a swampy area. They're showing it being buried and being pushed upon. If we look to help us kind of try and remember that, next to coal, they tell us it's made from compacted plant remains. And we talked about that in class. Base your answer to question 19 through 21 on the diagram below, which represents a scheme for classifying rocks. The letters A, B, and C, and X, Y, and Z represent missing labels. So we've got these rocks, and here's our A, our B, and our C, and we're missing some information in there, and they want us to fill it in. So the first one, question 19 says, if the rock in circle A formed from limestone, it would be called, so if the rock in circle C formed from limestone, it would be called, so we have limestone, but now it's a metamorphic version of limestone. If I look here, my metamorphic version of limestone, I look through, here it mentions limestone. So when limestone goes through metamorphism, it becomes marble. So 19 is C. 20, which process would form the type of rock that is represented by circle B? So I'm going to look up here at circle B. They show me these are rocks. I've got sedimentary over here. These are non-sedimentary, metamorphic. So this is going to be some sort of igneous rock. They tell me it's granite. If I don't know that granite is an igneous rock, I can look on my reference table, pages 6 and 7, until I find it and read the name of the table. Granite is igneous, and if we look, igneous rocks form from the solidification of magma. And if I look here, they talk about melting and solidification. So 20 is safe. 22. Which rocks could be represented by circles X, Y, and Z? So if I look back, X, Y, and Z are all rocks that have formed from the compression and cementation of sediments. So those are sedimentary rocks, to be specific, clastic sedimentary rocks. So I look through the names of my choices that they give me, and I compare them to the choices here. When I do that, only B has clastic sedimentary rocks. Base your answers to questions 22 through 24 on the graph below and your knowledge of earth science. The graph shows the temperature, pressure, and depth environments for the formation of 3 major rock types. Pressure is shown in kilobars. Letters A through D identify different environmental conditions for rock formation. Which rock is most likely to form directly from rock material at a depth of 30 kilometers and a temperature of 1,000 degrees Celsius? So I'm going to go to my axis that says depth, find 30 kilometers, go to my axis that says temperature, find 1,000, see where they intersect. They intersect near here. This says the formation of magma and igneous rocks. So I need an igneous rock. So right off the bat, I can get rid of quartzite and shell because that's metamorphic and that's sedimentary. That leaves me with these two. And then we had done this one in class as an entrance slip. We talked about why it couldn't be B because B is extrusive. Extrusive rocks form near the surface. B or D, granite, this is an intrusive rock, which means it forms inside Earth. So the choice is D. At what pressure and temperature is sand most likely to be compacted into sandstone? Sandstone is made of sediments. That's a sedimentary rock. So I'm going to look over here where it talks about sedimentary rocks. That ranges in pressure from 0 to 4, and it ranges in temperature from about 0 to 200. I'm going to look for a number that fits in that range. The only one that does is A. 23 is A. 24, which letter represents the environmental conditions necessary to form gneiss? So gneiss is a metamorphic rock. I'm going to look up here where it talks about metamorphic rocks. They break it down into contact metamorphism and regional metamorphism. If I look, gneiss is our regional metamorphic rock. So I know I'm zeroing in somewhere on this arrow band. And if I look, that arrow band has the letter C. So 24 is safe. 25, the flow chart below illustrates the change from melted rock to basalt. So they're telling us it's igneous 2 ways. They're saying it's melted. They're telling us it's basalt. The solidification of the melted rock occurs. So we're going to go to our igneous rock chart. We're going to find basalt. Here's basalt. Basalt is an extrusive rock, which means it exited Earth when it formed. It cooled quickly on Earth's surface or very close to it. So it's rapid cooling. And because it rapidly cooled, it didn't have enough time for its crystals to really grow. So it's a fine-grained rock. 26, which graph represents the relative densities of 3 different types of igneous rocks? So you're going to go to page 6 again. Look at the density section here in the middle. They show us on this side, left is lower. Over here on the right, it's higher. So if I'm a rock on this side, I'm going to have the lowest density. I'm going to be a middle density. I'm going to be a higher density, highest densities. So with that information, I look. Rhyolite should be the lowest. Andesite should be in the middle. And basalt should be the highest. The only graph that shows that is D. '27, the cross-section below represents a portion of Earth's crust. Letters A through D are locations within the rock units. So they give us a key here. They say this is igneous rock. They show us these little hairs coming off of it. These represent contact metamorphism. So that's where the heat and the pressure from the igneous rock changed these rocks that are nearby into their metamorphic version. And they're saying at which location is quartzite most likely to be found. So I'm going to look at quartzite on my metamorphic rock chart. If I look at quartzite, it says it's the metamorphism of sandstone. Okay, but now I need to know which of these symbols represent sandstone. I look at my sedimentary rock. Dots represent sandstone. So C would be a letter that is most likely quartzite, the metamorphic version of sandstone. 28, the diagram below represents the geological processes that act continuously on Earth to form different types of rocks. So they tell us A has weathering and erosion, deposition, and compaction. And if I look here, compaction, deposition, these are words going into sedimentary rocks. B says melting followed by cooling and solidification. If I look here, I have melting and solidification going into igneous rocks, and then heating and pressure accompanied by chemical activity. So if I look here, I have heat and pressure, and that's going into metamorphic rock. So now I just figured out what A, B, and C are: sedimentary, igneous, metamorphic. From there, I can see A's are going this way, so that's my sedimentary rock. B is going this way, that's my igneous rock. C's are going this way, that's my metamorphic rock. I look for the chart that lists that in the correct order that I just determined, and it is B. Okay, 29 was on the last two tests, and we're still having trouble with it. Here it is again. They give you the side of a cube, and they want you to find the volume. You could just do side squared, or volume equals length times width times height is probably the formula you are more familiar with. So 2.2 times 2.2 times 2.2, you put that into the calculator and you get 10.65 centimeters cubed. This was on the last two tests. This test, we did better on this one. As shown below, an empty 1,000 milliliter container has a mass of 250 grams, and they tell me that right down here. When it's filled with liquid, the container has a combined mass of 1,300 grams. They want to know what is the density of the liquid. So first I need to know my density formula is mass over volume. I need to know the mass of just the fluid. So I take the mass of the graduated cylinder and the fluid, and I subtract the mass of the empty graduated cylinder. I get 1,050. I divide that by the volume, which is 1,000, and I get 1.05 grams per milliliter. Question 31, we all did really good on this one. This one was on the last test also. Which diagram most accurately shows the cross-sectional shape of the Earth? Earth is an oblate spheroid. That means it's a little flattened on the poles, a little wider in the midsection, but it is so slight that our eye still sees it as a perfect circle. So we picked the one that looks like a perfect circle. It is D. Question 32, an observer in New York State measures the altitude of Polaris to be 44 degrees. The location of the observer is. So to do this, you need your Earth Science reference table, page 3. You need to find 44 degrees, and you need to know that the latitude equals the altitude that you see Polaris at in the night sky. If I'm at 44 degrees, the closest city to me there is Watertown. So Watertown sees Polaris at a 44-degree angle. Okay, question 33, there's a topographic map. In which general direction is the stream flowing? The contour lines, when they cross the stream, make this V shape. The V shape points upstream. Water flows downstream in the opposite direction. So in this case, it's flowing this way, which is southeast. This question had a lot you had to kind of go through to do. It says, base the answer to your question on 34 through 37 on the photographs below and your knowledge of earth science. The photographs show 8 common rocks, or excuse me, 8 common rock-forming minerals. So minerals, I know it's Earth Science Reference Table, page 6. The first question says, identify the mineral shown that can scratch all of the other minerals shown. If you can scratch all of the minerals, you are the hardest mineral, and every other mineral has a number less than yours. The highest mineral number here is quartz. I just went through on the back page. I found each mineral, like for instance, quartz, and I went to the hardness column. Identify the mineral as either felsic or mafic. So I went to page 6 of my Earth Science Reference Table, and I saw if the mineral was on the felsic side of the chart, which is left, there's felsic, or the mafic side of the chart, which is right. So when I do this, potassium feldspar.
The restorative council meeting today will be held in a library classroom instead of the DLR. The restorative council meeting will be in the library classroom. See you in a few minutes. Thanks.
Potassium feldspar and quartz are on the left side of the chart, and olivine and pyroxene are on the right side of the chart. Identify the 2 most abundant elements by mass in Earth's crust that are part of the composition of all 8 of these. So you just had to go to the front page of your Earth Science Reference Table, find the column of Earth's crust by mass. The 2 most common are here, which is oxygen and silicon. I check it against all of the minerals on the front page that we were just on there. So biotite mica, for instance, it has oxygen, it has silicone. Muscovite mica, it has oxygen, it has silicone. I go through for all of them. On all of them, I see the chemical formula or symbol, which is Si and O. So there's my answer for 36. 37, identify the 2 minerals shown that exhibit fracture as a dominant form of breakage. So I'm just going to compare these minerals here and look at the column labeled cleavage and fracture. If it is fracture, it has a check on the right-hand side. When I do that, I see that the mineral olivine has fracture. I also see that quartz has fracture. So those are my 2 minerals that have fracture. And I'm just going to write them right here. Question 38, describe the texture shown on this metamorphic rock that indicates it could be schist. So here's my metamorphic rock. They want to know what the texture of schist is. So I'm going to go to schist. I'm going to look in the texture column. It is mineral alignment or foliated. You just needed to write that down. For 39, based on the minerals present, identify the relative color and density of the igneous rock compared to the match of an igneous rock with the same crystal size that is darker. So if I look here, this has potassium feldspar. I'll be right with you. Potassium feldspar is my favorite because it's on the left side of the chart. So we know that this rock is lighter in color and that it is also lower in density. And then the last question, question 40, identify the environment of formation of this igneous rock. So I need to know its crystal size. I look at a crystal, I measure it out on a piece of paper. I see that none of them are less than 1 millimeter. We already said it's on the left side of the chart. So these are coarse crystals ranging from 1 to 10. So this is granite. If you have any further questions, make sure you ask me before the due date. Again, this is due next Friday. You go through, you explain how to answer each question. Staple it all together and turn it into the appropriate minute. Have a wonderful day.